Let us look at next example. Yes. Find the volume of the domain that lies in the first octant bounded by the tetrahedron with these four vertices. So first we have to plot the domain. So that domain is in the first octant and it is bounded by a tetrahedron. So let us plot that tetrahedron. So let us look at where these vertices are there. These are the vertices of that tetrahedron. So let us plot that figure. Yes. So this is 0, 0, 0, the origin. Then this is 1, 1, 0, 1, 1, 0. Then 1, 0, 1, 0. Yeah, this is 0, 1, 0 in the y-axis. And finally 0, 1, 1. 0, 1, 1. Where it is? Yeah, here. So these are the vertices of that tetrahedron, and that tetrahedron is shown here. This is a pyramid kind of object. This is the first phase, this is the second phase, and one more phase it will have. That is to the other side, which we can't see from here. This is one side, this is another side, and back side. So this is that. Okay. So volume of the tetrahedron. This volume we have to find out. Volume of this tetrahedron we have to find out. So volume is equal to triple integral over d dv. Integrand is equal to 1. Now to evaluate this integral we use Fubini's theorem. So what we do is we first project this tetrahedron onto the xz plane. So this is the shadow region. That means essentially you are performing integration with respect to y first. There are several ways to do this. We can do this integration in 6 different ways, but here we are following in this way. Project this region D lying inside this tetrahedron onto the xz plane. So this is the shadow region, right? This is the shadow region. Now y variation. When you project onto the xz plane, integration with respect to y first. So fix a point x comma z in that xz plane and draw a line m parallel to the y-axis. Where it enters the region, that is the lower limit of integration, and where it leaves the region, that is the upper limit of integration with respect to y. Okay, so we should know what is this plane. So what is this plane? What is the equation of this plane? So how do you write down the equation of a plane? Equation of the plane. So if you know a normal to the plane and a point through which the plane passing through, then you can find out the equation of that plane. So one point is 0, 1, 1. The plane passes through this point. So this can be taken as P naught 0, 1, 1. So let us write this plane. Which plane? This plane. This plane passes through passes through 0, 1, 1, P naught 0, 1, 1, and a normal vector I have to find out, normal to this plane. So normal vector n is equal to Okay, so this plane passes through this point 0, 1, 1. Where is 0, 1, 1? Yes, here. And it also passes through this point 1, 1, 0. I want a vector perpendicular to both these vectors. So n is equal to determinant ijk, ijk 0, 1, 1, and then 1, 1, 0. So what I will get? So that is equal to vector I into 0 minus 1. So it is minus 1 minus vector j into 0 minus 1 again. 0 minus 1 again. So it is minus 1 plus vector k into j into 0 minus 1. Yes, j into 0 minus 1, correct. Vector k into 0 minus 1. So minus 1 again. So that is equal to minus I plus j minus k. In other words, this is the same as minus 1 comma 1 comma minus 1. Now let Px comma y be any point on this plane. Let us say here, this is the point Px comma y comma z. So this is the point P naught x naught y naught z naught. So the vector P comma P naught is perpendicular to the vector n. So dot product must be equal to 0. That is how we write down the equation of a plane. So x minus 0 comma y minus 1 comma z minus 1 dot product with n. So minus 1 comma 1 comma minus 1, that is equal to 0. So if you simplify this, what I will get? X minus 0 into minus 1, that means minus 1 into x plus 1 into y minus 1, that means y minus 1 plus minus 1 into z minus 1. So minus of z minus 1 equal to 0. Simplifying this, what I will get? It is y. So here I have minus 1 and another plus 1. So they cancel each other. So you have y minus z equal to x, or y is equal to x plus z. Y equal to x plus z. That is the equation of the line. So let me remove this minus z from this side. So y is equal to x plus z. So this plane is the equation of this plane is y is equal to x plus z. Yeah, I have here y is equal to x plus z. So any line that passes through a vertical line parallel to the y-axis, passing through the point x comma z, will first enter the region at y is equal to x plus z and leaves the region. What is this region? This is precisely the plane y is equal to 1. Here y is constant in this plane and x and z vary. So the plane is y is equal to 1. So the y limits of integration are y limits of integration are x plus z to 1. So let us substitute first. So this is equal to integral y varies from, it enters the region y is equal to x plus z and leaves the region y equal to 1 dy. Oh, what is this? Now z variation, z varies from where to where. So again go to the figure, look at the shadow region. So this is x plus z is equal, okay, now this is the shadow region. How do you obtain this shadow region? You solve these two equations simultaneously, upper and lower. So y equal to x plus z and y equal to 1, you solve simultaneously. So you will get x plus z is equal to 1. So x plus z is equal to 1, that is a line in the xz plane, and this is that line. It will pass through this point and this point. Now what is the z limits of integration? So z varies from where to where? So this is z is equal to 0 and this is z is equal to 1 minus x. This line L leaves the shadow region at z equal to 1 minus x, enters the region at z is equal to 0. So the y limits of integration are z is equal to 0 to z is equal to 0 to 1 minus x dz, then integration with respect to x. This is equal to x varies from where to where? X varies from here x equal to 0 and x equal to 1. So these are the x limits. So x varies from 0 to 1. And when you evaluate this, you will get the answer. You will get the answer is equal to 1. So volume equal to 1. Remember, this can be evaluated in 6 different ways. I want you to practice all those different ways to make confidence upon yourself. Thank you.